So now we can close with some extra practice, some 2 example problems. So if you want to pause the video here, you can do that, and then come back and we can do them together. So I'll give you a couple seconds to pause the video, work on it by yourself if you would like. Okay, here we go. So this first one, I want to find vertical asymptotes, horizontal asymptotes, and holes. So first, I think what we should do is we should factor the top. So if you recall, you can factor the top by, well, it's x squared minus 4. So what I like to do when I factor quadratics is put x here, and then there's a negative, so there has to be a plus and a minus. My bad, a plus and a minus. So now it's 4, so factors of 4, we have 1 and 4. Well, if you're doing plus 1 minus 4 or plus 4 minus 1, you're going to get some x term in the middle, which we do not have. So it has to be the factors 2 and 2, and if they're the same, it doesn't really matter where we put them. So x plus 2 over x minus 2, and then we can simply just write the denominator again, x minus 2, x plus 3. And I shouldn't forget my y equals. There we go. So let's look for holes. So we can see here that they share the x minus 2 factor in the top and in the bottom. So we can cancel those. So if we set our cancel term equal to 0, x minus 2 equal to 0, we get x equals 2. So there's a hole at x equals 2. Oh, I forgot to mention as well in the first example for holes, is that once we find where the hole is, the x value of the hole, we want to plug that in to find the y value. So if we plug in x equals 2 to what we have after canceling, which after canceling we have something that looks like this, x plus 2 over x plus 3. We plug in 2 to the top and bottom for x, so 2 plus 2 is 4 over 2 plus 3, so 4/5. So y equals 4/5. So our hole would be exactly at 2 4/5, or 2.8. 2, 0.8. So that's where a hole is at in the function. So we found a hole. Are there any more holes? Well, nothing else cancels, so it doesn't appear that there's any more holes. Let's look for vertical asymptotes now. So let's look at the denominator for vertical asymptotes. We can set the bottom equal to 0, and I hope you can see that x would equal -3 when the bottom is 0. So there should be a vertical asymptote at x equals -3. Are there any more vertical asymptotes? Well, there's nothing else at the bottom, so it doesn't appear so. Now let's look for horizontal asymptotes. So we can see now that the degree in the top and bottom are both 1. So the coefficients of the highest degree term are just 1 and on the top and on the bottom. So 1 over 1 is 1. So there should be a horizontal asymptote at y equals 1. So I think that's all, so we can check that in the graph. Oops. My bad, hang on. So, yes, x equals -3. We have a vertical asymptote, and we have a horizontal asymptote at y equals 1. Unfortunately, on the math whiteboards, the holes don't appear, but if we zoomed in on the point 2, comma 4/5, or 2, comma 0.8, which would be right here, if we zoomed in with an extra magnifying glass, we would see that, in fact, this point does not exist. But from a zoomed out perspective, and of course we know a graph is just an infinite amount of points. It's basically a pattern of an infinite amount of points. So at this exact point, there is a discontinuity or a hole where the graph does not exist. But you just can't see it from a zoomed out perspective, if that makes sense. So we can just leave this here for now, and then we can work on our second problem. So our second problem is, this one's a little simpler. Y equals 5 over x minus 1. So, are there any holes? Well, there's nothing to cancel, so there's not going to be any holes. Let's test for vertical asymptotes. Set the bottom terms equal to, or set the bottom, bottom equal to 0. So x minus 1 equals 0. Appears there's going to be a vertical asymptote at x equals 1. And now horizontal asymptotes. So in this one, actually, the degree in the bottom, or the denominator, is greater than the degree up top. So if you can remember what that means, but even if you can't remember, let's try plugging in a really large value to see what happens as x would go to infinity. So if we plugged in, let's say we plug in x equals, let's do 1,000 again. So we get 5 over 1,000 minus 1, 999. So 5 over 999, that's going to be really, really big. Oh no, my bad. Really, really small. So the larger the bottom, or the denominator of a fraction gets, the smaller the value will be. So we can see here that there should be a horizontal asymptote at 0 when the degree of the numerator is less than the degree of the denominator. So there should be one at y equals 0, which is correct. So there should be one at y equals 0. So let's see if we're right. So a vertical asymptote, x equals 1, it appears that is true, and a horizontal asymptote at y equals 0, which appears to be true as well. We can see that in the graph. So those are some examples and practice on how to find horizontal, vertical asymptotes, and holes, just based on looking at the function. And I hope that helps, and thank you for watching and listening.